Hi guys, we start with the unit 1 of the object-oriented programming. The topic for this unit is object-oriented paradigm. We have 4 subtopics. The first one is object-oriented programming introduction. The second one is abstraction, classes and objects. The third one is inheritance. And the fourth one is polymorphism. We start with the first subtopic, and the first thing that we need to know are some concepts, and we start with the first question about what are programming paradigms. While developing an application or solving a simple problem, we often say, if I had more time, I would have written a simple program. The reason is we made a program with greater complexity, and we have some rules for that. The less complexity we have, the easier it is to debug and understand. The more complex a program becomes, the harder it is to work on it. When managing complexity, it's a programmer's main concern. So how do programmers deal with complexity? There are many general approaches that reduce complexity in a program or make it more manageable. One of the main approaches is a program paradigm. The term program paradigm or programming paradigm refers to a style of programming. It doesn't refer to a specific language, but rather it refers to the way you program. Programming languages are usually categorized under the term paradigm. These paradigms define how a language looks and feels like, what it does, and for what purpose it should be used. And we have some common paradigms. There are two main approaches to programming. The first paradigm is the imperative programming that focuses on how to execute, defines control flow as statements that change a program state. Some examples of this kind of, or the use of this kind of paradigms in the languages are C++, Java, Kotlin, PHP, Python, and Ruby. And we have another one, it's declarative programming, that focuses on what to execute, defines program logic, but not detailed control flow. Some examples are SQL and regular expressions. Next, we have widely considered the main programming paradigms. The first one is the structure programming. It specifies the steps a program must take to reach a desired state. Some language that has this kind of paradigm are C, C++, Java, Kotlin, PHP, and Python. And we have the procedural programming that is derived from structured programming based on the concept of modular programming or the procedure call. C++, PHP, and Python are some languages that use this kind of paradigm or have some specific or are specific for this kind of paradigm. The next is functional programming, that treats programs as evaluating mathematical functions and avoids states and mutable data. C++, Excelin, F#, Java since version 8, Kotlin, Python, Ruby, Scala, and JavaScript are some languages that support this kind of paradigm. And of course the object-oriented programming, that is the main, or we are focusing in this kind of paradigm in this subject, and the object-oriented programming organizes programs as objects. Data structure consists of data fields and methods together with their interactions. C++, C#, Java, Kotlin, PHP, Python, Ruby, Scala, JavaScript, and many other languages supports this kind of paradigm. Of course, the more commercial or more common in the development environment are C#, Java, PHP, that we use this kind of paradigm on these languages. And the following are common types of programming that can be implemented using different paradigms. The event-driven programming. Program control flow is determined by events such as sensor inputs or user actions or messages from other programs or threads. JavaScript is the kind of paradigm that support this type of paradigm. Java it's a language programming, sorry. And then last one is the automata based programming. A program or part is treated as a model of a finite state machine or any other formal automaton. As abstract state matching language, it supports that kind of paradigm, and we center or focus on the object-oriented programming. Then the object-oriented programming is a set of description, design, modeling, and programming techniques that are used to develop projects efficiently, where objects are the main building blocks. There are numerous formal definitions for this term, which can be summarized as a form of system implementation in which programs are organized as cooperative collection of objects, each representing an instance of a class and whose class or classes are members of a class structure defined by relationships. Everyday life is full of objects, some tangible and some not. For example, a table, a book, a tree, a car, etc. are examples of objects. However, you must be aware that objects don't necessarily represent things, but can also model people, animals, or other abstract or intangible entities. For example, bank account, an electronic invoice, an email message, etc., where each object has features and associated actions that distinguish it and serve to identify it. Additionally, an object can be related to other objects to provide global solutions to real-life problems. These are not all of them. Instead, new paradigms are created when a new developer starts to write an application in different paradigms. That is because paradigms are not required to be followed. You can create your own separate paradigm, create the rules and laws, and then implement it in your own application development lifecycle. Object-oriented programming paradigm also came into existence through this kind of philosophy. Many programming languages came into existence following this paradigm. We mentioned that some examples are C++, Java, C#, PHP that are common in the for that kind of paradigm. The paradigm of object-oriented programming focuses entirely on the objects. This paradigm considers everything as an object, so the definition of the object may be it's in object-oriented programming. An object is a variable, class instance, function, or a data structure. that can hold some information in the form of a field and can perform anything as a function. The objects are also able to depict inheritance from each other. Currently, the object-oriented programming paradigm is the most popular among programmers and focuses on trying to simulate or model the objects of everyday life. To understand it better, we will analyze various concepts. And we have a picture with some of them. The first one is a class. It is an abstraction that represents a set of objects with a common actions and interface. It can be said that a class is a mold or template that generally represents the features and actions of an entity that is used to create objects. Values represent the features that objects can have, and actions represent the actions they can perform. For example, if a class called student is defined, the features may be the enrollment number, name, date of birth, address, etc., while the actions it can take are the enroll, accredit a subject, fail, or graduate. When defining a class, it is recommended to use a singular noun to identify it. For example, card, teacher, check, etc. A class then is a user-defined blueprint or prototype from which objects are created. It represents a set of properties or methods that are common to all objects of one type. In general, class declaration can include these common components in order. We list them, and there are modifiers. A class can be public or has default access. The class name, the name should begin with an initial letter. We use a capitalized by convention. The superclass, the name of the class parent or the superclass, preceded by the keyword extends. A class can only extend subclasses or extend one parent. And there are optional. We have interfaces that are optional too. A comma-separate list of interfaces implemented by the class, preceded by the keyword implements. A class can be implemented more than one interface. And the last one is the body. The class body is surrounded by braces. To understand it better, we will make an analogy. Suppose that a construction company wants to build houses in a subdivision and hires an architect for it. First, the architect conducts research to determine the requirements, style, and needs to design the type of architectural project desired. As a result of said investigation, the architect draws a plan showing the dimensions, location, distribution, facilities, etc. of the houses requested. And based on this plan, he builds each of the houses in the subdivision. In this analogy, the plane corresponds to the class, and each of the houses are the objects obtained from that classes. That is, the class contains the design elements that all the objects generated from it will have. With this, you can set the features and actions that objects will perform. The features are defined through attributes or properties, while the actions are executed from methods. And what is an object? It is a particular element of a class that has its own features and actions different from those of other objects. And an object can be a physical thing like a pencil, a table, or a bicycle, but it can also be an abstract thing like a check, bank account, electronic invoice, etc. We know that something is an object if it has a name, its features can be defined, and it is capable of carrying out some activity or behaving in a certain way. For example, each of the students at the university represents objects from a student class, while their own individual features and actions, with their own individual features and actions. That is to say, each one has a registration number, a name, a date of birth, address, etc., different from of the rest of the students, and can register, accredit, fail, or graduate differently from the others. In another example, suppose you want to make an object model to manage the files of the dogs attended in a veterinary clinic, where the data is the name of the pet, the breed, the color, and its actions, its or are eating, barking, and sleeping. When a class should be designed with these elements, that will include all the files of the analyzed dog. To do this, you can define a class called dog that contains these elements, so that various objects are generated from it, each or one for each dog served. Although several objects can be created from the class or the same class, this doesn't mean that all elements will be exactly the same, since each one can have particular features that distinguish it from the others, even if they all belong to the same class. And we have an example from the features from Firulais that has a color brown, and the actions are the same from the other dogs. It is a basic unit of object-oriented programming and represents the real-life entities. A typical Java program creates many objects, which, as you know, interact by invoking methods. An object consists of an state, an actions, and an identity. The state is represented by attributes of an object. It also reflects the properties of an object. The action is represented by methods of an object. It also reflects the response of an object with other objects. And the identity, it gives a unique name to an object and enables one object to interact with other objects. Now we know other concepts related with object-oriented programming. The first one is the object instance or an instance. An instance is the concrete creation or manifestation of an object from its class, which has its own features and actions that identify and differentiate it from the rest of the objects. In other words, an object is an instance of a class. We have already analyzed that the class represents the abstraction that describes the features and actions of some entities, and that objects are particular creations of that entity. Then the process of creating the object is known as the generation of instances. To show it better, we will make the following analogy. A cake pan represents a class, since it has the features, for example, size and shape of a cake. However, by baking different cakes and creating multiple objects, each can be decorated differently. That identifies and makes them unique, resulting in the creation of multiple instances of the mold class. Then it can be said that an instance is its declaration of an object from a class. Each instance of the class has status, actions, and identity. The state represents the particular values of the features of the object. The action refers to the actions it can perform, and the identity allows to recognize an object belonging to the class with a unique name that distinguishes it from other objects. And we have some example in the picture in the slide. The next is the access control to the elements of a class. The object-oriented design allows you to establish controls to restrict the visibility and access to the members of a class in such a way that they can protect and hide the data and the actions defined in the class from the access of other classes. When defining the elements of a class, the features or actions, you must specify the level of restriction that will be assigned to each of them using access modifiers, so that some will be for private use while others will be for public access. Private members of a class are hidden from other classes. That is, they can only be accessed by the internal members of the class that contains them, while public elements are visible to the other classes and therefore can be accessed by them. To better understand this, we will use the following example. Suppose that a small grocery store has a counter from where a person attends customer in such a way that when a customer needs, you order an item from the person at the counter who looks for the product on the corresponding shelf and delivers it for you. Or when a supplier of the products arrives to fill the small store, he leaves the order for new merchandise to the person who attends the counter so they can verify it and place it in the right place. In this sense, the items sold by the store are considered private access, since neither the customer nor the supplier have different access to the shelves where the products are located, and to access them they require from an intermediary, in this case the person at the counter, who acts as a trusted internal element for the store. However, in many supermarkets, the merchandise is available directly to customers in such a way that the customer enters the supermarket and directly and personally takes the products he wants to buy without having to request it from an employee. In this sense, the articles are considered public access modifiers that will be explained later. And for now, we need to know what is an attribute. An attribute represents a feature or data of an object. An object can have many attributes, and attributes are controlled through variables. Because of this, it is not enough to identify the data that the objects will have. The data type must also be determined. The number and type of attributes declared in a class depend to a great extent on the intended use of objects created from that class. This means that objects can have a large amount of data. However, not all are necessary for the model applied in solving particular case studies. This is called the level of abstraction, which will be explained later. To better illustrate or understand, let's look at the following example. A school requires an object-oriented model to manage its students' records, whose data are enrollment key, name, grade, group, average, address, sex, age, telephone number or phone number, and some others. And among its actions are reading, researching, playing sports, participating in a social club, and some others. However, for this project, Not all of your data or all of your actions are necessarily and only those elements relevant to this case are selected. The chosen attributes are declared within a class through variables. Attributes can classify into instance variables and class variables or static variables. An instance variable is an attribute that is created for each instance obtained from that class. This means that each object has this attribute, but with a particular value, which determines its state. Therefore, a copy of each instance variable is created for each generated object, and memory space is reserved for each of the variables. A static or class variable is one that is uniquely created and shared by all objects generated from a class. That is, unlike instance variables, static variables are not copied to every object. This means that during the execution of a program, a single memory space is reserved for a static variable regardless of the number of objects generated, in such a way that all shaded class or static variables are identified by placing the static modifier in the class attribute declaration. Static variables are used to manage common features for all objects or to store features that depend on all objects. Let's consider the next example, the object-oriented model of a marketing company that sells some import products has a class whose attributes are the key, description, unit of measure, and unit price. However, it also requires controlling the exchange rate to make monetary adjustments when making the purchase or sale of its products. For this, it relies on the declaration of a static variable that stores the unique value applicable to all products. And now we need to know what is a method. An object not only stores data, but also performs some actions that define its actions. Methods are the activities that objects can do or have and are regularly implemented through modules. The concept of method exists from the structured programming paradigm and consists of writing a code segment once, grouping it in a module and invoking as many times as necessary for it to carry out any activity. Now, in the object-oriented paradigm, the methods plays a fundamental role, so that the objects show certain actions and contribute to the solution of problems. They also provide the possibility of cooperation between various objects, since they can be prepared to send and receive messages from other objects. Unlike other programming paradigms in which the data and methods were separated, in the object-oriented paradigm, all the elements of the object are encapsulated in the same package. That is, the attributes and actions performed by the objects are defined within the design class, and therefore all the objects created from it have them. Consider the previous example that defines the features and actions of a student. The attributes of the student, however, it is important to mention that the actions carried out by each student must also be included in the design of the corresponding class. That is, the class must also have the definition of the method, such as reading and investigating. A method is a collection of statements that perform some specific task and return result to the caller. A method can perform some specific task without returning anything. Methods allows us to reuse the code without retyping the code. And in Java, every method must be part of some class, which is different from other languages like C, C++, and Python, for example. Methods are type savers and help us to reuse the code without retyping the code. In general, the method declaration has 6 components, and we have a representation in the slide from the method. The first component is the access modifier that defines access types of the method from, or in example, from where it can be accessed in your application. And particularly in Java there are 4 types of the access specifiers. The first one is public, that is accessible in all classes in your application. The protected, that are accessible within the package in which it is defined and in its subclasses. And private, that is accessible only within the class in which it is defined. And default, that it's accessible within the same class, and package within which its class is defined. And if you don't put any access modifier, the default or declared, it's the kind of modifier that the method can have. And the next component is the return type, the data type of the value returned by the method, or void if doesn't return a value. If you have or you need to return some data or something, you need to put the keyword return and next the value. And if you didn't return anything in the method, you need to put the keyword void in the declaration of the method. The next component in the method declaration, it's the method name. The rules for field names apply to method name as well, but the convention is a little different. You use a camel case for this notation. The next component is the parameter list. Comma separate lists of the inputs parameter are defined, preceded with their data type within the enclosed parentheses. If there are no parameters, you must use empty parentheses. And the next is the exception list. The exception you expect by the method can throw, you can specify these exceptions. And the next one is the method body. It is enclosed between braces. The code you need to be executed to perform your intended operations, it's between these braces, or are between these braces. And next we need to know what it's a properties. A property is a member of the class that provides a way to access the attributes of the class. The accesses can be to consult, modify, or calculate the value of an attribute. And you can use the word attributes or properties as synonymous for this kind of for this definition. However, in the strict sense, a property is a mechanism that acts as an intermediary, that is, it acts as a channel through which an attribute is accessed to consult or modify its value. For example, if an attribute is private, then it is hidden from other classes, and in many classes it will be necessary to access it to execute some processes. Because of this, then a broker is required that is able to access the attribute to query or modify its value. This broker can be a property or a method. A property can have a code associated when regarding or modifying the value of an attribute, so that when it accesses the value of an attribute, it can execute a set of instructions with a specific purpose to control said value, such as validating make it a suitable value according to the data type of the attribute, or make sure that the value is within an allowed range. Properties can have two accessors, get and set. The get descriptor is used for data reading properties, that is to query the value of an attribute, while the descriptor set is implemented when you want to modify the value of the referred attribute. A property can be read and write when both get and set descriptor are implemented. It can be read only when only the get descriptor is implemented, or write only if only the set descriptor is implemented. A self-implement property is a conscious way to handle the data in a class without declaring the corresponding attributes. That is, when a self-implement property is declared, the programmer doesn't declare the corresponding attributes, but the self-implement property acts as a data itself. And in this case, the compiler automatically adds a private and invisible one attribute or declaration for this attribute. And we need now to know that the definition for constructor and destructor of a class. The constructor is a special method that is automatically executed when a class is initiated. That is, it is invoked immediately after the creation of an object, generally used to initialize the object, or generally used to initialize the object, although you can implement any sequence of instructions. The constructor can receive parameters, however, a value like a function is not inherited and cannot return, and must also have the same name as the class. The parameterless constructor is known as the default constructor. A class can have several constructors. It's not enough to implement them so that they receive different parameters. This means that an object can be created and initialized in several different ways. The constructor access modifier must always be public to allow the creation of the object from any part of the program. Then the destructor is a special method that is automatically executed when an object is destroyed. This allows the memory that the object occupied to be released, and the destructor can't receive parameters or return a value and must have the same name as the class. Only it is preceded by a symbol. A class is not allowed to implement multiple destructors, and the symbol that is precede the destructor is the tilde. And then the message for an object-oriented system to offer a global solution to a problem, it must have a cooperative set of objects which must communicate with each other to share data and use it when performing a process. One way to get objects to collaborate with each other is through the exchange of message. A message is a A message is a message that objects send each other to communicate and is typically accomplished using parameters sent and received by the methods. And the overload in object-oriented programming, the name of overload is known as the ability to have several members of a class with the same name but with different functionality and therefore with different action. It can be implemented by creating methods with the same name but with different amounts and types of parameters. The same method of a class can perform different actions depending on the parameters sent, that is, the invoke and execute method is selected based on the parameters. It is worth mentioning that the constructor of a class can be overloaded, but its structure can't. Operators may also be overloaded to extend their functionality by diversifying their operating range. Now we need to know what is or the definition about abstract class. Commonly, a class is used to generate instance of it, that is, to create objects. However, an abstract class is a type of class from which an instance or object can be generated, although it is paradoxical due to the nature of the class. They are used only as a mold to inherit from it, that is, they force inheritance. An abstract class can declare normal methods and properties as well as abstracts in which its implementation is not defined but its task delegated to the subclass that inherit it. This means that the subclasses have the obligation to develop the design detail of their abstract components, that is, the abstract elements must be modified in the inherited classes. And similar to an abstract class, an interface is a set of method and property declarations that don't have any implementation but are performed by whoever inherits it. However, the difference is that the interface has no variables or constant and can't inherit from other classes, but it can from other interfaces. They are abstract or not implement declarations that serve as a reference to classes to inherit from them, with the intention that the classes implement these declarations. In a way, they can be considered a reminder to make sure that the classes that inherit them implement the mechanism to perform certain actions. An interface is a kind of contract that defines the actions that the classes derive from them must carry out, although it doesn't specify how to do it. That is, it forces a class that inherits from an interface to implement the action defined in the interface. The features of the project-oriented programming are the following, or are considered the pillars or its pillars, and this is abstraction, encapsulation, inheritance, and polymorphism. Abstraction allows objects to interact without having to know the details of how they work. It is to focus on implement or important aspects of the object under study, ignoring the irrelevant aspect that can distract attention. For example, the TV remote control is a physical object with a name that has features such as weight, size, shape, etc., and can perform some actions such as turning on or off, changing the channel, increasing or decreasing the volume, etc. However, we aren't regularly interested in knowing how it performs these actions. We simply care that when pressing certain buttons, it executes some actions. So the user of the remote control doesn't need to master its internal functioning. It is enough to know the actions performed by each button and know how to invoke them. Abstraction also allows selecting those elements of the classes that are relevant to the problem to be solved depending on the approach with which the problem is analyzed. That is, the same object of study can be analyzed from various aspects or points of view, which can generate a large number of features and actions. However, not all of them will be important for a particular problem of said object, which results in erasing those aspects of that. Although they are part of the object under study, are not significant for the case analyzed. For example, a pit can be analyzed from the point of view of the master or from the perspective of its veterinary doctor. And this can be led to various object-oriented analyses with levels of abstraction or different levels of abstraction. And data abstraction is a property by the virtue of which only the essential details are displayed to the user. The trivial or non-essential units are not displayed to the user. For example, a car is viewed as a car rather than its individual components. Data abstraction may also be defined as the process of identifying only the required features of an object, ignoring the irrelevant details. The properties and actions of an object differentiate it from the other objects of similar type, and also helping classifying or grouping the objects. For example, in a real-life example of a man driving a car, the man only knows that pressing the accelerators will increase the speed of a car, or applying brakes will stop the car, but he doesn't know about how on pressing the accelerator the speed is actually increasing, and he doesn't know about the inner mechanism of the car or the implementation of accelerator, brakes, or other things in the car. This is what abstraction is. In Java, it is achieved by interfaces and abstract classes, or abstraction is achieved by interfaces and abstract classes. We can achieve 100% abstraction using interfaces. We have some example in the slide about an abstract class. But abstract classes and abstract methods has some important points. The first one is an abstract class is a class that is declared using abstract keyword. The second, an abstract method, is a method that is declared without an implementation. An abstract class may or may not have all the abstract methods. Some of them can be concrete methods. And a method-defined abstract must always be redefined in the subclasses, thus making overriding compulsory, or either make subclass itself abstract. Any class any class that contains one or more abstract methods must also be declared with abstract keyword. There can be no object on an abstract class. That is, an abstract class can be directly initiated or instantiated with the new operator. An abstract class can have parameterized constructor, and default constructor is always present in an abstract class. And then we need to when to use abstract class and abstract methods. There are situations in which we will want to define a superclass that declares the structure of a given abstraction without providing a complete implementation of every method. That is, sometimes we will want to create a superclass that only defines a generalization from that will be shared by all its subclasses, leaving it to each subclasses to fill it in the details. For example, in the layer before, we consider a shape example, perhaps used in a computer design system or a game simulation. The base type is shape, and each shape have a color, size, and so on. From these specific types of shapes, we derive or inherit circle, square, and triangle. In this example, we consider just circle and rectangle, each of which maybe have additional features and actions. For example, certain shapes can be flipped, and some actions may be different, such as when you want to calculate the area of the shape, the type hierarchically embodies both the similarities and differences between the shapes. And we have some advantage of abstraction. It reduces the complexity of view the things, avoids code duplication and increases reusability, and helps to increase security of an application or program, as only important details are provided to the user. The next thing we need to know is about encapsulation. Encapsulation allows to include in the same container both the features of the objects and their actions. Unlike other programming paradigms where data and models were separated, in the object-oriented programming there are key packaged in the same container. This also allows you to set usage restrictions, since you can define the aspect that will be published of the objects and those that will be kept hidden in such a way that the objects present mechanism to interact with other objects, and with this only the respective mechanism must be known without understanding the implementation details. Encapsulation defines the level of access to the elements of a class. This level determines the access control to the attributes, methods, and properties defined as a public, private, or others. Encapsulation is defined as the wrapping up of the data under a single unit. It is the mechanism that binds together code and data it manipulates. Other way to think about encapsulation is it's a protective shield that prevents the data from being accessed by the code outside this shield. Technically, in encapsulation, the variables or data of a class is hidden from any other classes and can be accessed only through any member function of one class in which they are declared. As in encapsulation, the data in a class is hidden from other classes using the data hiding concept, which is achieved by making the members or methods of a class as private and the class is exposed to the end user or the world without providing any details behind implementation using the abstraction concept. So it is also known as combination of data hiding and abstraction. Encapsulation then can be achieved by declaring all the variables in the class as private and writing public methods in the class to set and get the values of variables. Some advantages of encapsulation are data hiding. The user will be or will have no idea without the inner implementation of the class. The increased flexibility, that we can make the variables of the class as read-only or write-only depending on our requirement, and you need to use the set and get to change this or access this. The reusability, that encapsulation also improves the reusability and easy to change with new requirements. And finally, the testing code is easy. Encapsulate code is easy to test for unit testing. Then the encapsulation versus data abstraction. In the encapsulation side, we have that is data hiding, or the information is hiding, while in the abstraction is the detail hiding or the implementing hiding. While encapsulation groups together data and methods that act upon the data, and data abstraction deals with exposing the interface to the user and hiding the details of implementation. The next concept we are studying is inheritance. In its most elementary form, when an object is instantiated or created, it acquires the features and actions defined in the class to which it belongs. However, there are also occasions when classes can be organized hierarchically, where classes located on the higher level share their features and actions with classes on the lower levels. With this, it is possible to define new classes from existing ones. For example, if you define a base class called musical instrument that has certain features and actions, then from this class you can define new classes. For example, one class or one subclass called a string instrument, other wind instrument, and another one percussion instrument, which acquire all the features and base class shares. By doing this, you define that both string, wind, and percussion instrument are musical instruments. However, inheritance can be applied at various hierarchical levels, such that a subclass, for example, for a string instrument, you can inherit from other classes, for example, guitar and fiddle. And in this case, you can be or you can look that a guitar and the violin are a string instrument, and that in turn or a flute is a wind instrument that is also a musical instrument, and that both drum and tambourine are percussion instruments, and similarly they are also musical instruments. Inheritance is a mechanism that allows in hierarchically classifying a set of classes, and its main objective is to reuse code, since it allows designing new classes derived from other previously designed in such a way that allows all the elements defined in the base class are automatically based on the subclasses or derived classes without rewriting them. We have some kind or different types of inheritance. We look the first one, it's the single inheritance. A single inheritance, subclasses inherit the features of one subclass. That means that class B or class A serves as a base for the derived class B. We have a multiple inheritance. In multiple inheritance, a derived class will be inheriting a base class, and as well as the derived class also act as a base class of other classes. In the example, the class A serves as a base class for the derived class B, which in turn serves as a base class for the derived class C. In Java language, a class cannot directly access to the grandparents members. In hierarchical inheritance, this one class serves as a superclass or a base class for more than one subclasses. In this case, the class A serves as a base class for the derived B and C classes. And now inheritance is an important pillar of object-oriented programming. It is the mechanism in Java by which one class is allowed to inherit the features of other classes. The important terminology for this is the superclass, that the class whose features are inherited is known as a superclass. The subclass, that is the class that inherits the other class, is known as subclass. The subclass can add its own fields and methods in addition to the superclass fields and methods. And the reusability, the inheritance supports the concept or this concept. By in example, when we want to create a new class and there is already a class that includes some of the code that we want, we can derive our new class from the existing class. By doing this, we are reusing the fields and methods of the existing class. And how we use the inheritance, for example in Java, the keyword used for inheritance is extends. Or we need to use the extends keyword to refer we are using inheritance. And we have another kinds of inheritance that these are not supported in the Java. The multiple inheritance. In multiple inheritance, one class can have more than one superclass and inherit features from all parents' clauses. In the example, we have the class C that is derived from the interface A and B, and the hybrid inheritance, that it is a mix of two or more of the other types of inheritance, and this doesn't support, or Java doesn't support this kind of inheritance. We need to know now the important facts about inheritance in Java. Default superclass and superclass can only be one: the inheritance constructor and the private members inheritance. For the default superclass, except object class, which has no superclass, every class has one and only one direct superclass. In the absence of any other explicit superclass. Every class is implicitly a subclass of object class. In the superclass can only be one. It's because a superclass can have any number of subclasses, but a subclass can have only one superclass. This is because Java doesn't support multiple inheritance with classes. That is something that we show in the examples above. Inheriting constructor, a subclass inherits all the members, for example fields, methods, and nested classes, from its superclass. Constructors are not members, so they are not inherited by subclasses, but the constructor of the superclass can be invoked from the subclasses. And the last important fact about inheritance in Java, it's the private member inheritance. A subclass doesn't inherit the private members of its parent class. However, if the superclass has public or protected methods like getters and setters for accessing its private fields, this can also be used by the subclasses. And what all can be done in a subclass? In subclasses, we can inherit member as is, replace them, hide them, or supplement them with new members. The inherit fields can be used directly, just like on any other fields, and we can declare new fields in the subclass that are not in the superclass. We can declare new methods in the subclass that aren't in the superclass, and we can write a subclass constructor that invokes the constructor of the superclass either implicitly or by using the keyword super. We can write a new static method in the subclass that has the same signature as the one in the superclass, thus hiding it. And we can write a new instance method in the subclass that has the same signature as the one in the superclass, thus overriding it. Now we need to know about polymorphism. Polymorphism refers to an object exhibiting different behaviors depending on the context where it is, changing the way of reacting to certain requests. This allows two methods to implement different actions, even if they have the same name, depending on the object that contains them or the values it receives. There are several ways to implement polymorphism. The most common is when a base class inherits a method of two subclasses or derivative classes and gives them the opportunity to modify the implementation of said inherited method, so that each of the derived class adapts the way to implement and execute the inherited method according to your own needs. For example, the dog give a chest objects have the option open defined. However, although it is done differently from each of them, each class knows how to do it. The word polymorphism means having many forms. In simple words, we can define polymorphism as the ability of a message to be displayed in more than one form. In real life example, a polymorphism, a person at the same time can have different features, like a man at the same time is a father, a husband, and an employee. So the same person possesses different actions in different situations. This is called polymorphism. Polymorphism is considered as one of the important features of object-oriented programming. Polymorphism allows us to perform a single action in different ways. In other words, polymorphism allows you to define one interface and have multiple implementations. The word poly means many and morphs means forms, so it means many forms. In Java, polymorphism is mainly divided into two types: the compile type polymorphism and runtime polymorphism. The compile time polymorphism is also known as static polymorphism. This type of polymorphism is achieved by function overloading or operator overloading. The method overloading, when there are multiple functions with same name but different parameters, then these functions are said to be overloaded. Functions can be overloaded by change in number of arguments or in change in the type of arguments. Operator overloading. Java also provides options to overload operators. For example, we can make the operator plus for a string class to concatenate two strings. We know that this is the addition operator whose task is to add two operators. So a single operator plus, when placed between integer operators, adds them, and when placed between string operators, concatenates them. And runtime polymorphisms, it is also known as dynamic method dispatch. It is a process in which a function call to the overriding methods is resolved at runtime. This type of polymorphism is achieved by method overriding. Method overriding, on the other hand, occurs when a derived class has a definition for one of the member functions of the base class. That base function is said to be overriding. And then for the compile type, we are overloading, and for the runtime, we are overriding. That are the difference between these two types of polymorphism. And then the advantage of the project-oriented programming. There are the maintains, the reusability and reliability. The maintains object-oriented programs are easier to read, understand, and control of program complexity is achieved by hiding information that allows only the most relevant details to be visible. Modifications can also be made simply by adding, deleting, or changing objects. Reusability. Objects and modules can be used numerous times and in different applications. And in the reliability, object-oriented programs are often more reliable as they are based on the use of already defined objects that have been extensively tested. And that's it. We finished with the first unit. And see you soon, guys. And remember, proudly UTR.